Mineral characteristics. So a mineral is a naturally occurring inorganic solid with a specific chemical composition and a definite crystalline structure. And Earth's crust has about 3,000 different minerals. Now, most of these are not common. There's about 30 or so that are common, but we have about 3,000 different minerals that have been identified. Minerals form rocks and shape Earth's surface, and then some minerals have changed history, like tools made from iron. Discovering metals that we could extract from different minerals has changed the world. So naturally occurring and inorganic, what does that mean? So this means they're formed by natural processes. So synthetic diamonds and other man-made substances are not minerals. We can produce diamonds that have the same properties as naturally occurring diamonds, but they're not considered minerals because they don't occur through natural processes. All minerals are inorganic, which means that they are not alive, they never were alive, and they're not produced by living things. So for example, salt is a mineral. Salt is made of sodium and chlorine, so it's sodium chloride. It's not living, it never was alive, and it's not produced by living things, so it's inorganic. Sugar, on the other hand, which looks a lot like salt, is not a mineral because it is organic. It came from a living thing. It comes from sugar cane or sugar beets, or there's other plants we can use to extract sugar from. But sugar comes from living organisms, so it can't be a mineral. Coal is also not a mineral because it was formed from partially decomposed plant remains. Definite crystalline structure. So atoms in minerals are arranged in regular repeating geometric patterns. So this forms a crystal, sort of like our lattice we have over here. Okay, so you have these alternating silver and green atoms here. So they're not silver and green, but this is like the structure of sodium chloride or table salt. So it forms a crystal, forms a repeating pattern, which is basically what a crystal is. So a crystal is a solid in which the atoms are arranged in a repeating pattern. These can form large, well-defined crystals if they form in an open space, but it's much more common for minerals to form in confined spaces, resulting in smaller crystals that grow together. More like the quartz down here has grown in a confined space, and you have a bunch of quartz crystals that have grown together, whereas this quartz at the top here grew in an open space, so you get a nice, well-formed crystal. And then solids with specific compositions. So solids have definite volumes and definite shapes. Gases have neither of those. They have indefinite volumes and indefinite shapes. So gases cannot be minerals. Liquids have definite volumes, but they do not have definite shapes. So liquids could also not be minerals. So no gas or liquid is considered a mineral. Each mineral has a unique chemical composition. Now this may vary slightly within a specific range of elements that make up this composition, but it doesn't vary a whole lot. A few minerals are single elements, things like copper and silver and gold, carbon, sulfur, etc. Some of these are found as single elements. So most minerals are compounds. So for example, quartz is SiO2, which is silicon and oxygen, and it's actually called silicon dioxide. Pyrite is iron and sulfur, FeS2, and that's actually iron 4 sulfide. Won't get much into the naming of those, but just kind of know these are made of multiple elements that are bonded together. Now, variations in composition. So in some minerals, chemical composition can change slightly depending on the temperature at which the mineral crystallizes. So the main elements and the crystal structure remain consistent, but there are slight variations in that. So for example, plagioclase feldspar, which is an aluminum silicate mineral, so it's got aluminum, silicon, and oxygen in it. But that's one example. So at high temperatures, it forms a calcium-rich anorthite, which basically is aluminum, silicon, oxygen, and calcium. At lower temperatures, it forms a sodium-rich albite. So again, you have your aluminum, you have your silicon, your oxygen, and all of these. In the anorthite up here, you have calcium, and in the albite down here, you have sodium. And then at intermediate temperatures, it may contain both calcium and sodium, and they kind of may form layers. So you may have a layer of calcium-rich feldspar, and then a layer of sodium-rich, and then a layer of calcium-rich, and then a layer of sodium-rich. And they just kind of layer on each other. Kind of happens at intermediate temperatures, and they both kind of form. Different appearances are due to different chemical compositions and growth patterns. Growth patterns of the crystals, that is. So some forms of plagioclase feldspar. Again, we have our albite down here on this end. And this is sodium, aluminum, silicon, and oxygen. On the other end, you have anorthite, which is calcium, aluminum, silicon, and oxygen. And then these in the middle are going to have a mix of sodium and calcium. This oligoclase here is going to have more sodium and less calcium. This labradorite is going to have more calcium and less sodium. So it'd have more calcium and less sodium. Okay, but you kind of get this range if you have a lot of sodium over here and you have a lot of calcium over here. And it has to do with the temperature at which they form. At low temperature, you get more sodium incorporated into the mineral, and then at higher temperatures, you get more calcium incorporated. So here we have a summary of mineral characteristics. So coal, for example. So if we kind of read through our properties here. So is it inorganic? Well, coal is not. It's not inorganic. It is in fact organic. It comes from plant remains. So it's not a mineral. Brass. Well, brass is inorganic, but does it occur naturally? No. This is a man-made alloy. Obsidian. Is it inorganic? Yes. Does it occur naturally? Yes. It's volcanic glass. Is it a crystalline solid? No, because it does not have a regular repeating pattern. That's actually the definition of glass. Like I said, it's volcanic glass. It doesn't have a crystal structure to it. Basalt, it's inorganic. Yes. Does it occur naturally? Yes. Is it a crystalline solid? Yes. Does it have a consistent chemical composition? No. So basalt has a wide range of chemical composition, so it's not going to be a mineral. And then get to something like fluorite. Fluorite is inorganic. It does occur naturally. It is a crystalline solid, and it does have a consistent chemical composition. So that is considered a mineral. So you have to answer all four of these yes to actually have a mineral.